Hi, and welcome back to our channel. Today we're diving deeper into statistics, one of the most essential tools in data science. If you ever wondered how to analyze data, create histograms, or understand probability, you're in the right place. Let's get started. So we'll begin with a discussion on histograms. A histogram is a type of graph that shows how often different values appear in a data set. It looks like a bar chart, but instead of individual data points, it groups values into bins or ranges. Let's see how that works. So step one, divide the data into bins. So imagine you have a data set of people's weights and we group them into bins, say from 100 to 110 pounds. Next bin is 110 to 120 pounds. Next is 120 to 130 pounds, etc. Step two, we assign the data to each of the bins. For example, if someone weighs 115 pounds, they go into the 110 to 120 bin. Step 3, count the items in each bin. So we count how many data points fall into each bin. Then we go to step 4 and create a chart. Using Excel, we select the data and generate a histogram. Alternatively, you can try to create a chart directly from the raw data and ask Excel to show you the histogram from the chart options. Then right-click on the created histogram, pointing at the bottom axis when right-clicking, and select how many bins you'd like to cut the data. In our illustration, we use 5 bins. Then we can right-click on any of the bars to show the data label so that we can see the values of the bar charts. So we move on to probability. Probability is how likely something is to happen. It's always between 0 or impossible and 1 certain, or 0% up to 100%. For example, flipping a coin has 2 outcomes, heads or tails. So assuming a fair coin, since both are equally likely, each has a probability of 50% or 0.5. Using our histogram, we can make probability statements like if we have 15 people in our data set and 3 people weigh between 110 to 120 pounds, then the probability of picking someone in that range is 3 out of 15 or 20%. Next, we move on to probability distributions. A probability distribution is like a map showing all possible outcomes and how likely they are. There are 2 main types: the discrete distribution, when outcomes are countable, like rolling a die from 1 to 6, and a continuous distribution, when outcomes can be any value within a range, like human heights. One of the most important probability distributions is the normal distribution, or the bell curve. It's symmetric, with most data points clustering around the mean. So some of the key features are the following. The mean, the median, and the mode are all equal. Most values fall near the center. The further from the center, the less likely the value is. So in a normal distribution, 68% of the data falls within 1 standard deviation from the center. So what is the motivation for standard scores? Now take a look at the data shown here. The question is 4 farther away from 3 in set 1 as 8 is from 6 in set 2, or as 12 is from 9 in set 3? Mathematically speaking, yes, they are. For example, is 4 farther away from 3 in set 1 as 8 is from 6 in set 2? Well, 4 minus 3 is equal to 1, and 8 minus 6 is equal to 2. So clearly, in absolute distances, 8 is farther from 6 as 4 is from 3. But how about on a relative basis? Is 4 farther away from 3 as 8 is from 6 on a relative basis? Well, think about it. They're just multiples of each other, so theoretically, on a relative basis, since they are multiples of each other, then on a relative basis, it shouldn't be farther out. And if we take a look at taking the distance and measure it in terms of the standard deviations, we're finding out that both are 0.71 standard deviations away from their center. So is 4 farther away from 3 in set 1 as 12 is from 9 in set 3? Again, the answer is on a relative basis, no. They are both 0.71 standard deviations away from their center. So how do we compare data points from different data sets? And that's how we use this information. We use the z-score. It tells us how far a value is from the mean measured in standard deviations. So the formula looks like this, where x is the data point, mu is the mean, and sigma is the standard deviation. Knowing this intuition of distance from mu in sigmas, if the data is normally distributed, then we can find out the ranges that give defined probabilities, knowing only the mean and standard deviation. Again, this is the empirical rule, the 68.3 for 1 standard deviations from the mean, 95.4, around 2 standard deviations, and 99.7 falling within 3 standard deviations. So given a data set that is normally distributed and mean is equal to 10 with a standard deviation of 2, find the range of numbers which will cover 68.3% of all the data. Solution: 68.3% of the numbers should lie within 1 standard deviation to the left and to the right of 10. Since 1 standard deviation is 2, then to the left and right, that means 8 and 12, which is a distance of 1 standard deviation from 10. So the numbers between 8 and 12 will contain 68.3% of the data. So that's how it's used. Now, mapping to a standard. All normally distributed data will map to the standard normal distribution with mean 0 and standard deviation of 1 by just measuring the z-scores from the original data. The whole area under the curve is 100%. Half of the curve is 50%. Cutting a portion on both sides or two tails such that the area covers up to 2 standard deviations on both sides give you 95.4 of the data. If we cut one side of the curve or only one tail, we need to figure out the probabilities involved in this manner. For example, if in a two-tail distribution, 68.3% will lie within 1 standard deviation from the mean, then that means roughly 15.85% is cut from both sides, and that defines 1 standard deviation away from the mean. If we need to get all the standard deviations to the left of 1 standard deviation, it's a simple matter of taking the rightmost 15.85% of the data and subtract that from 100%, and we get roughly 84.15% of the data that lies to the left of 1 standard deviation or the one-tail distribution. Using z-scores in Excel. So in Excel, we can easily use formulas that compete for the z-scores or the reverse of probabilities. So just use the functions norm s dist to find the probability from z, and norm s inverse or norm s inv to find z given the probability. For example, norm as dist of 1 gives 84.13%, meaning 84.13% of the values are to the left of positive 1 standard deviation. So you'll have to note this, that when working with probabilities in Excel and the bell curve in Excel, so in Excel, the convention is to use a one-tail distribution. So kindly remember that. So that's a wrap for today. Today we learned about histograms, probability, normal distributions, and z-scores. These concepts are fundamental in data science and analytics. See you next time when we talk about hypothesis testing and linear regressions under machine learning. If you found this helpful, give this video a thumbs up, subscribe for more, and let us know in the comments what you'd like to learn next.